Okay, let's take a shot at this. We'll look at a couple of tubes in here and see what we can see if some of them are bad. And I doubt that very much. Okay, so lighting this and making a video is a little tricky, getting the dial to be visible, somewhat visible anyway, on the screen for you to see. So I've set this up for a 12BE6. Isn't that really what I have here? 12BE6. Let's just double check. 13 for the filament voltage, 4 for the signal level, 8L for the bias, 51763. 51763. 3000. 3000. If you're wondering what all these tubes are, they're all just waiting for attention on the tube tester. Look, these are all bent. This tube's taking a bit of a beating here. Oh my gosh, look at that. Not for me. Here we go. So we'll do a shorts test first, and then the next test will be to measure the transconductance, or mutual conductance, whatever you want to call it. And on this meter, it will come up to the 1570 number. So 1570, that's 1500 right in the middle there. So that's where we're going. Okay, tube's warmed up. Doesn't have any shorts in it. So the meter would jump way up if there was anything serious in there. There's nothing in there. GM, does it go up to the middle? Wow, it's way over. So this is a good tube. That's a good guy. So he's not responsible for any weakness in the performance of this radio. Try another one here. This will be the IF amplifier tube, and I think it's a 6BA6, isn't it? Made in Canada. Marconi Radiotron 6BA6. Yep. Okay, so we'll find 6BA6 here. You might as well watch the whole process. 13-4-10L 52763. 52763. 4120. 4120. 33. C. This one, if it's good, or actually this is actually the reject point. It's got to be above 960, so about here. Okay, we'll plug them in. What about double checking? That's risky. Give it a moment. Short check. No shorts. Pretty much if there was a short in any of these tubes, that radio wouldn't have worked, I'm pretty sure. Again, just above, just around the 1000 mark here. That's not very good. I have socket problems on my tube tester. Oh my. Okay, so in this situation, I've usually made a mistake with the tube tester. Let's go over it again. 12BA6. 13-4-10L. My slip 52763. 52763. 4120. 4120. 33. Let's see. Oh, now it's decided to work a bit. Did it take the tube that long, or it's probably the socket? Yeah, it's probably the socket. Well, you got a bad tube. This tube should be up around the 1000 mark. Okay, let's just do a little sensitivity check by wiggling the bias a little bit. It's not doing much of anything. And the meter sensitivity, no, that's not going to account for this. This tube is bad. Okay, that's low. I think will make a difference if we change this. I have to go find one in my collection. Okay, check my inventory. I should have 10 of them. in a box labeled 12 volt miniatures right here. So I have multiples of one of a tube, and it's a valuable tube to me. I'll put them all together in a bag. I'll label it 12 BA6. These are all tubes I've tested quickly to make sure they operate, but I don't know the quality of them unless they're really sick. Like that tube I just tested, it would not go in this bag. It would head for the garbage. Actually heads for a bag of rejected tubes because I just can't bring myself to throw these things away. So I have a big bag of hundreds of dead tubes. Okay, out with this one. In with this one. Now I'm going to stick this back on the radio here because it won't take me long before I get confused around which is what. Okay. Shorts. Shouldn't be any. What do you show me? Look at that. Now that's a huge difference. That's well over the 1,000. So we got a good guy here. 12, eh? So, what difference will this make in the radio? Now, the radio was barely receiving anything with its original. Take this out. I'll put this guy in. And there's a shield. Have a shield on it. Okay, now is that going to make any difference? It's a good question. Oh, it must make a difference. There we go. That was full power from the start, no restrictions on it. What are we hooked up to here? We're hooked up to the outdoor antenna. Well, that's interesting. Okay, I just made an important observation there. So this is the signal coming from my outdoor antenna, and this is probably grounded at some point somewhere along the line, just based on where the cables are going. Stick this ground on, the radio works better. The antenna's not helping much, the ground is. But why is that? I think because the signal's coming on the antenna, and it would love to work against something. So if you put it on a ground like this, it has something to work against. If you take away the ground, and you get kind of this. So that kind of makes sense. I don't know. Yeah. So the situation in my shop here is this is plugged into a rather complicated AC feed going through an isolation transformer. I'm going to switch it to just a regular outlet, take this ground off and see if it works better. Okay, out you come. As regular an outlet as I've got in my shop. I'm going to flip the plug around in the outlet. And see any different? See sparks? Oh, this is so exciting, you gotta see it. So for a decent voltage with no power behind it. Would I get a shock if I grab this and then grab the radio? I don't know, maybe you can try. I'm not going to try. If I took a voltmeter, a high impedance voltmeter here, I'd read probably, well, probably 80, 90 volts or something like that. AC. The whole shebang is there, 130 volts. But it's through the capacitor and the 270K resistor. I'm going to get a low impedance meter and we'll see what we can read. This actually isn't the lowest impedance meter either. This guy's not so bad. He's 2 joules. Hey, I got 2 joules. 2,000 ohms per volt. It's not very good. That's exactly what I want. So what this meter requires is a fair bit of power to operate. And I think we're going to get a totally different reading. I'm going to put this on, it's on 150 volts AC right now. Just do the same thing. Put that in here. Okay, does Jim have egg on his face? Oh, he's egg. A huge amount of egg all over my face. So I thought this wouldn't even read. That sound you're hearing is coming from a wireless speaker. It has nothing to do with anything over here. It has to do with my house audio system. Wow, okay. Well, there's enough juice there to operate this meter. Is there enough juice there to juice me? I think the idea is it won't kill you. if you were to contact the chassis and then ground yourself. I have to go a little further with this. I have another meter. I have a actual technician's meter here. This one is probably better. Probably. Usually they say right on them what the ohms per volt is. So the ohms per volt is just a really easy way of keeping track of the input impedance or resistance on these. You just take the scale you set it to and then multiply it by the ohms per volt. So if you got a 200 volt scale and you got 1,000 ohms per volt, it's a 200,000 ohms when it's on that scale. That's where the ohms per volt thing comes from. Don't see it written here anywhere. But I think this is a better meter than this. So you know, the age difference here. Older being better. Okay. What are we trying to do here? We're trying to find out if this thing is really dangerous or not. I'm going to do something really crazy here. Can it light a light bulb? No, it cannot light a light bulb. It cannot light a light bulb. Okay, so if this light comes on, then this is definitely a really dangerous situation here. Suppress the sparks anyway, but no, there's just no way there's enough current coming through. It's coming through that 270K resistor. Okay, that's enough for me to accept that all is normal there. Oh! What the heck just happened there? Okay, so I don't want to move. I'm cut the power. Oh, I can't cut the power. Plugged it right in the outlet. Okay, out of the outlet. Wow. Okay, so look at that. Jeez. What did I do here? So this is definitely my antenna lead. But this probably meets up with power system neutral somewhere in my house going through equipment. Now that was definitely a big banger. Did I contact something in behind the radio? Okay. There's nothing in there. Oh my god! What happened? And then this huge bang, but then the clip went on and everything was normal. Holy smokes. Because I blew something out at the other end of this cable. Something at the other end of this cable is on fire right now in my house. I don't know what happened there. I don't know. Oh my gosh, I don't know. Yeah, good time to stop right now. Go chat with my wife, tell her I'm still alive, and see if there's a fire burning somewhere in our house. Oh, man. Okay, so I've taken a few minutes to think about what has happened. I really don't want to let this go, because I absolutely was not expecting that at all. In fact, I just finished convincing myself that couldn't happen. So what to do? So I'm going to repeat what I did without putting that right on there. Now, I had this plugged into my isolation transformer, but I had plugged it right into an outlet. The chassis should be isolated from anything to do with the outlet by that capacitor and that resistor. It's a fairly large capacitor. Could that just be current flow through the capacitor? Wow. And then along with the big bang, I then had the capacitor, I then had the wire clipped on there. Now either lost contact, fat chance on that, or after the pop there was no problem, which I can't really explain either. Because you would think if you can get a big pop like that, that there's a fault current there and something is going to give up, the ghost. Fuse, a circuit breaker, or something. And it didn't look big enough, to be the kind of fault that would trip my house breaker. And of course, the light stayed on, everything stayed on. Discharge of a big capacitor, but there shouldn't be any. Shouldn't be any. Is that what happened? I discharged the capacitors? Okay, so I'm going to plug this in a regular outlet. As regular as they get in my shop. Now, danger. I used to, in my old shop years ago, I had another little light I called the hot chassis light. I was working on a 5-tube radio. I would connect the light between the chassis and a hydro ground point somewhere. And just have the light sitting. And if at any moment I did something that caused the chassis to come up to 120 volts of real power, that light would come on and I'd know, woo, danger. It makes me think I should reinstitute that. And that would be a good way to test this again. But I did test it with a light bulb. And nothing showed up. So I plugged this in an outlet, but it can go in either way, this or that. And I don't know which way it was. I had measured 120 volts there. Do I have a little Christmas light handy? Do I have a little Christmas light? Maybe stay away. I might. My turn. So this is an automobile light meant for 12 volts. Let's see what happens with that. That's pretty cool. I do not have a Christmas light in here. How about that? Do we dare give it a try with just one of these? This guy takes a fair bit of current to light up. But it's only 12 volts. If there's actually more than 12 volts here, this will be another exciting moment I don't need. No, I don't have a Christmas light there. Okay, I'm off in search of a Christmas light bulb. How do you like that? Santa's trim shop for outdoor light bulbs. So these are a little bigger than what I was expecting. How many watts are these? Made in China. Energy saver 7-watt lights. 120 volts. 7 watts. Is this going to show up? It's tempting to put that right on there again. Wait a minute, you know what? Maybe I don't have this in the 120 volt danger setting. Let's just check that. It's definitely in the danger setting. Like if I reverse the plug here, I think that'll fall to 0. But the thing about this is if I turn the radio off, I'll go back up to 120. Probably. Let's get it back there. So we haven't got enough power there to operate any of these lights. Even a 7-watt light. Yet there was a big bang there. So there's another odd thing happening here, which really is a real long shot. If we look up, 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 way up there. What I've got is the radio's antenna wire hanging from a little bit of copper wire hanging out from way up above. So it's bare copper here onto bare copper. Let me just let go of the camera here so I'm not holding on to it while I do this next thing. So you see that you can hear this connection. The problem is this goes up. It may come down. I can see it up here, and the wire just goes up, just kind of hooked in here, and I think it may be making copper contact with this. In many cases, this wouldn't be connected to anything, but I don't know. I mean, there's a lot of it here. Is that part of the story? I can't imagine. The antenna is isolated with a capacitor. I can't imagine that's part of this weird story. It should not make the story weirder. So what do you do about that now? So let's go back to once this thing's installed in its cabinet. This is the kind of radio where the metal knobs protrude through here. I'm pretty sure if we look at the knobs, we can see. Yeah. So these knobs have no collar on them to reach down inside. So these are protruding through the top. And when the knob's on it, you can't touch this. I'm assuming touching this is the same as touching the chassis. It can and can't be. You never know. And the other thing is the antenna. Can we get a read? 190. What's happening? My meter battery's quitting. Let's give the battery a break. And what do you say now? For crying Wow, this just gets weirder and weirder. Is that real? I do have another meter. Oh my, but I would hook the ground up if I used it, and that would be this meter. I don't want to put a ground on there. That's what I'm all scared about now. I am a scared puppy. Especially with a ridiculous reading. Let's get another meter here. This is just going crazy. Okay, I'll try this guy. Volts AC. Auto ranging. Okay. Volts. So did I see things? Did it say a lot more than 119 at first? I think probably my battery's going dead in this other. Okay, so now, now it's at the last minute. This radio's throwing everything at me. We're still back to the question of how dangerous is this, and how can you judge how dangerous this is? I mean, I could grab that and touch that, and then I can report very clearly how dangerous it is. I want to do that. Something that can run, that can show even less, even something that's going to show us how much oomph there is behind this. I could put a variable resistor in here and then adjust the value of the resistor and watch the voltage. If the resistor gets down around, a couple thousand ohms, and the voltage is coming down, that would suggest to me that there's not a lot to this. What have I got that I can put in there safely? None of those. Something like that. What is the resistance of that thing? Now I'm really having fun. There's probably not much resistance in it. $200 ohms. But 20 ohms. What did I put 20 ohms across that? What happens? What happens? Is this really a good way to do this? I have another. There's a more potent one there. This is a really, really amazing one here. Now it's not in the best of shape. This piece isn't supposed to move. This piece here. The slider is sliding on top of this metal. The metal is curved, and the only part that comes in contact is under the pressure point here. So what they've done is they've arranged this so the slider doesn't slide on the resistive material. The slider slides on some stainless steel or whatever this is and just pushes it into contact. Except the whole thing's turning now. It's not supposed to turn. It's supposed to stay like that. Isn't that interesting? Now this is really old. This is from a really old setup. But you can see that you could do that forever and not wear it out. No doubt back in the day they were having trouble making these things, and this was one way to protect the resistive element. Of course this one, I didn't really show it to you, there's wire wound around here. And the centerpiece is just picking off somewhere along the wire. Great. I'm just delaying things because I'm not sure what to do. 20 ohms, what's it going to do? Okay, we're going to find out. First of all, I'm going to pull this out completely. Put it this way. Stay prong up. Prong up. This thing, we will actually try to connect it to the slider. Maximum resistance to start with, 20 ohms. What have I done now? I haven't quite done the right thing. I haven't done what I intended to do. What I wanted to do was have this actually like that. I got another clip lead. Clip lead's not good for power type, current type stuff. It's fine when it's just voltage. So I'm trying to short the voltage out with a variable resistor. That's what I'm trying to do here. And we want it to be maximum, so we go here. Sorry, that was just a nervous thing. Yes, I'm nervous. Lots of things at risk here. Equipment, the radio, my reputation. No, that's been flushed down the toilet long ago, so don't worry about that part. Maximum, what do we get? I pulled the plug out, but I maintained knowing which way it was. I'm gonna shove this in, the radio will come on, and that little resistor will start smoking. Is it smoking? Look at the resistance now. The voltage now, 0.2 volts. That's with the total 20 ohms in here. Is that right? I've done something wrong here. Something's not right here. What have I done? Done something. Oh no, it's right. It's right. And so if I turn this down, this number should just go down, down, down. Down, down, down. So here, halfway, 20 ohms kills it. But typically a human being's around 1,000 ohms. It really depends. It really depends on the person. Depends on how much moisture's on your skin. I'm a moist guy. I'm moist all the time. I was working maintenance in an apartment building. I had an electrician in. He was doing some work, and I walked into the room where he was working, and all the outlets were being replaced at that point. He had all the wires hanging out of the boxes. And without saying anything or anything, he just walked up and he grabbed the white wire like this and the black wire like that, and I almost flipped out when he did that. He goes, "No power here." What? And I said to him, "What are you doing?" The guy was about 45 or 50. He goes, "Oh, don't worry, my hands are so dry I can't draw any current, so I discovered I can just grab the wires and tell which ones are alive and which ones aren't." Oh my God, I was at it. Yikes! Not a recommended procedure. Really. And if I did that, I'd be on the other side of the room. Okay, so what are we finding out? We're finding out there is something here. It doesn't explain the big pop. It doesn't explain the big pop. I always like something being discharged. That's why I was curious about the antenna. I didn't really explain that, but I thought maybe there's some kind of circuit through the antenna or something. I don't know. Okay, beat this one to death. Not sure if I really proved anything at all. One thing's for sure, you need to be careful with these radios. 5-tube radios and hot chassis and all that stuff. Okay, without getting myself exposed to danger. Yes, and the yeah, sounds like his battery's going down too. The danger with these radios is the 120 volts is on the chassis. You flip the plug around, you then turn the radio off, and the 120 volts is back on the chassis. I won't go into the explanation for that. It's actually a very simple reason, but it's a little hard to understand at first how that's happening. And that's what makes them so dangerous, because surely to goodness, if you snuff the 120 volts out on the chassis, turning the radio off can't bring it back, can it? Yes, it can. So you can get a shock at any moment with those radios on your bench. And be really careful about hooking up ground wires. And I normally don't have to be careful because I normally have this plugged into an isolation transformer, and there's no relationship between the ground here and the radio. Wow, man alive. Okay, so that kind of cleared my head right out. I don't know what I'm doing. What am I doing now? So just a quick review. Found a bad tube. Check the radio. Seemed to perform a wee bit better. Let's see if we can find another bad tube. Let's get going with that. Right, I haven't done it. I keep turning the power off to my bench outlet thinking the radio's going to go off. I've got to plug it in elsewhere. Let's plug it in here. No power. And what we're going to do is we're going to go after the yeah, I'm going to get my fingers burned if I'm not careful. We're going to go after the detector tube somehow. Yeah, right. That's not going to go in there. I need a tube puller tool. How hot is it, Jim? Not that hot. This should be a 12AT6, and it is. Okay, it's heading for the tester. Okay, first thing, let's get the tube here. First thing, I don't know how to end that sentence. Let it warm up for a minute. Not even a minute. Is there a short in that tube? No, there is not. So this tube has two diodes and a triode in it. We're testing the triode. The triode should show up as 780, so it only has to make it up to about here. And it's up around 1,000. So we know the triode's good. Now to test the diodes, you have to change some settings here. I'm going to pull the tube out. 01763. 01763. P000. P000. Sensitivity 45. Plate goes to A. That's very important. P1, P2. So there's a little thing here that says diodes OK. So all I got to do is just get up above where my finger is now, and we can be happy. Now there's two diodes to check. These are the diodes that are rectifying the output of the IF. The IF amplifier, the IF stages, the IF string, whatever you want to call it. Just check again. Shorts. New. Now we want to pull this one here, rectifiers and diodes. Oh, it's not up there. There's two of them, and to get to the other one, we flip the plate to plate 2. We'll do it again. Oh! Oh, that's the wrong button, wrong button. Oh, that's not even better. Probably bad contact, yeah. Oh, this is terrible. I really got to take the time to fix this. So we're still below the diodes okay there. And the other one is definitely lower yet. This tube's strong on the triode, but weak on the diodes. 12AT6. Okay, I'm gonna see if I've got some of those. Okay, so it turns out I don't have any 12AT6s, but according to my records, I have 18 12AV6s. There they are. 18 of them. And they are direct swappable. And this tube actually has a little more gain than the other tube, but there's some other variations that may counteract that. 12AV6. Does that mean the tube settings are exactly the same? That could be the case. Let's find out. I'm going to pull this guy out of here. Let's give him one last check. He's been sitting in there for a while. Still not making it. Seems higher. Nope. Still not making it. Put this over here. Right in the radio. There's the original 12AV. So let's check and see what changes I have to make to the settings here. 13. So it's looking for a higher signal. Okay. The bias. Oh, that's an 85. Jimmy, go back. Okay, back to the same signal. Signal 1. 19L. Okay, it's pretty close. That's 19L. So the bias a little different. 51760. Oh, I've got this set for it. No, do the diodes first. 1763. 01763. These should be the same. P000. Yeah. Sensitivity 48. A little higher. And A. Yeah. Okay. We'll check the. We'll start with checking the diodes in here. Check for shorts. Shouldn't be any tubes that had shorts when I was going through them in my collection all went into the no good bag. So there shouldn't be any shorts here. Oh, that's a mistake. Let's try that again. That might have been a bad mistake to make with this. Oh, maybe not. It's calling for it actually to be switched. Ah, lucky me. Okay, right on the diode check. Right up in the diodes okay area. That one too. Okay, so the diodes are good. Now we want to check the triode. Triode. Signal level 1. 19L. Right. These are all right. Oh no, they aren't. 51760. 12AV6. 51760. How does that compare to a 12AT? 51760. It's exactly the same. 12AV 0300. 35 sensitivity. F over to there. And it's supposed to read around 1000 on the meter here. Good. Tube back in. One of the things I find interesting when I go on the internet is all the discussions between people about this tube and that tube, and there's such a lively community of people fiddling around with vacuum tubes. It's really quite amazing to me. I thought I'd be the only guy left. No, there's a whole new breed coming up. Messing around with these guys. They seem to know a lot more than me too. Okay, we're all set. Just check for shorts, just in case. And we give it a test. Wow, way over there. So that guy's going in the radio. Okay, we'll take out the bad guy. What did I do with the other bad guy? Dark in here for me. There he goes. There he is. Okay, 2 bad guys. Okay, we're going to try this radio again. Lay him down just on his own wire. Oh, there we go. His own wire. We should all be on our own wire, shouldn't we? Okay. It's working. Just on his own lonely wire. Okay, I give that to be a no. I'm going to hook the antenna to that wire. Plugged into the isolation transformers. I'm not too scared. Here, in case there's going to be a big explosion here. No. One there. Needs a lot of antenna. Do I dare put that ground wire onto the chassis? I can, because this is plugged into an isolation transformer. Okay, game. Put on your sunglasses.
Protesting police shooting of Jacob Blake. This after taking some major heat for taking the ice back on Wednesday, as many athletes in sports hit the pause button. Here's a Ryan Reeves of the Vegas Golden Knights.
How is it feeling? I have the feeling this is 590. It's supposed to be around, looks like it's around 680 or so. Let me find out. So the reason I think that's 590 is they're talking about sports and it's the strongest station. And if you can only get one station, it's usually this one. 590 is that's way off, isn't it? I guess it's not way off. I'm going to do a little oscillator adjustment here. But first I want to verify whether this is really 590. Hmm. 590 up here. I'm right there. Sure enough, 590. Okay, so the radio is receiving 590. It's way off, and it is important to try to get this lined up with the dial because there's a tracking problem with the front end and the. I'm waving my hands around, not even on camera. So we will adjust this. So I will set this. So we're hearing the signal generator because it's set to 560 right now, but I'm setting it so I believe it's dialed in at 590. And now we'll make 590 show up here by adjusting the local oscillator. If I can see it. Well, it's in there. There's my little driver with the tape on it. It's wandered off. Okay, with the greatest of care. Not with that, like this. Just going to shorten it out. Okay, we're in. Bring up the signal generator. Ooh. Get the German money. Use the 1,000. Oh man. That doesn't want to turn. I'll make a little stronger screwdriver here. Wow. What's going on with the screw? There he is, coming. Something funny going on with that screw. So I think it's heterodyning with the actual station. So that should put 590 at about 590. Let's find out. Get rid of this. Get rid of all this. What did I do? I've left the signal generator on and removed the antenna. The external antenna. What happened? Now, is that 640? Okay, let's find out. If I just have this close enough. 640. 640, and when you look on the dial, yeah, that'll be past the 640. We should be able to get 3 stations on radios here. 640, 590. And 680. Very, very weak, if really nothing. Okay, uncouple the signal generator here. Okay, I'm going to try the other trimmer since we've worked the oscillator. Let's see what we get out of this. I normally do this the antenna trimmer at the high end. So I've opened it up quite a bit. Wow. I don't think there's anything more to get out of this guy. Wow, it's hot tube. That was the output tube there. Yeah, I just don't think there's anything more to get out of here. I'm going to take him somewhere else in my house and give him a test out of my shop and see what happens.